All right, now I want to do some sensitivity analysis to my solution. What does it mean, sensitivity analysis? A sensitivity analysis is when you examine your solution, a solution that you have already got, but by changing some of the parameters. All right, let's do that first graphically. Because you see, the benefits of graphical method is that you can visualize what's happening. So let's do that first. Okay, what we have done so far is, or to find the solution, we plot the line, we move it with the ruler away from the origin until it touched the last point, and this point was our optimal solution. Now let's do one more thing. Let's extend the binding constraint line, the yellow and the green line. Here we go. So I'm extending it, and I can see that my objective function line, this blue line, lies between these two. Okay, so it is constrained, or it's limited by these two lines. Let me rotate my objective function line, okay, anti-clockwise, and now it is that blue lines, dashed line. Do you think the objective or the optimal solution, the optimal solution changed? Certainly not, because the question is, can I move that now blue line away from the origin while I'm still in the feasible solution space? You can see that visually that no, it's not. So the answer is no. What if I rotated my original black line clockwise, and now it is showing like in this dashed blue line? Again, the same question, would the optimal solution change? The answer is still no. All right, let's rotate it further. Okay, or before that, sorry. So I can make a conclusion that when the slope of the objective function changes within limits, all right, which are these limits, this one and that one, the optimal solution was not changing. Let's move it away beyond the limits. So here we go. Okay, I moved it clockwise up to an extent where I went beyond the green line and beyond the yellow line, of course. So do you think now the optimal solution changes? To answer the question, ask yourself another question. Can I move this new objective function line away from the origin while I'm still in the objective feasible solution space? The answer is yes, because you can see that this segment now is inside the feasible solution space, which means it gives me more room to move away from the origin, which means increasing further the profit. So yes, I can do that. And look at this. Here we go. And now this is my new optimal solution. Let's do that also if I rotated my objective function line in anti-clockwise, and now it is this dashed line. The question is, can I find now a new optimal solution? And the answer is also yes, because now that I rotated it, I have part of it inside the feasible solution space, which means give me more room to move it away from the origin. And here we go. I'll move it away from the origin until it touches a new point, and now this is my new solution. So what's the conclusion that we can make? When the slope of the objective function changes beyond the limit, this is what we have seen, then the optimal solution does change. This is very important conclusion. However, these conclusions they are limited to the graphical method, and unfortunately graphical method can be used only when I have two decision variables, which would be often not the case in real life. So let me use these observations but in more general terms. So instead of objective function rotating, or sorry, the slope of the objective function changing, how can I replace that? Think about it while I'm erasing this for you so that you can see it clearly. What do you think? What can I replace the slope of objective function? What makes the slope of the objective function? What makes the slope of the objective function is the objective coefficients, right? So I can now replace these two observations with more general observations. Then when the objective function coefficients change within limits, And we'll talk about these limits later when we talk about the sensitivity report. All right, then the optimal solution does not change. And when the objective function coefficient change beyond the limits that we will be reading, these will be values, numbers that we will be reading, not any more lines, because unfortunately we cannot use the graphical method anymore. If we have more than two decision variables, then the optimal solution changes. It's very important to see that, so that when we be dealing with sensitivity report with numbers, you'll always remember what you have been seeing in the graphical method. All right, now let's see what happens to the optimal solution when the right-hand side of a value changes, not the objective coefficient. So my objective line will not change. The slope is not changing because I'm not changing the objective coefficient. What I'm changing, I need to change the right-hand side of that green line. Remember, this was represented or that was plotted here because we had a right-hand side equal to 22. It's not on this axis, right? So let me to put it here. It was 22. What if, and that was the inspection time available for me. So what if instead of I have only an inspection time of 22 hours, what if I had 28 hours? What do you think would happen to this line graphically? Of course, it will move, it will shift to the right. Here we go. And what's the effect of this shift on my feasible space? Look at this. Now, if you extend the yellow line, now I can see that the feasible solution space has increased. And here we go. Now it's that blue area, which puts now the objective function line that I did not touch. Now it has a segment inside the new feasible solution space. And why this is good for me? Because now it gives me more room to move it away from the origin, so maximizing further the profit or increasing further the profit while I'm still inside the feasible solution. So let's do that. And here we go. This is now our new optimal solution. So what the conclusion that we can make from here? That when the right-hand side value of a binding constraint, remember the green line was representing a binding constraint. So when the value of the right-hand side value of that binding constraint changes, the optimal solution changes. And this is something that we're going to see again in numbers when we're going to see the sensitivity reports.